Davao de Oro. Good morning, Z-eskwela listeners, especially to all grade 8 students who are listening to us right now. I am your radio teacher, Miss Sushmita Dayanara M. Lampagos from Andap National High School, New Bataan District. And together with me is Mr. Elizur M. Bucas from Monte Vista National High School, Monte Vista District. We are here happy to serve you for 45 minutes of bringing you with fun and exciting lessons in Science Grade 8. So, we hope you had already prepared your pens, record notebooks, and modules. And be sure that you already had eaten your lunch as we go through our discussion. Now, are you ready for today's lesson? That's good! Before we introduce to you our topic this morning, let us now have a short review of the previous lesson, which is about force. We know that force refers to the push or pull. Force also can make any object move faster, stop, or change its direction of motion. You even describe force by familiarizing some terms. The following are magnitude, direction, point of application, and line of action. We also read and identify the types of force, namely contact forces and non-contact forces. Contact force is a type of force where objects touch or have contact with each other. Some examples of contact forces are applied, friction, normal, and tension. While non-contact force is a type of force where objects do not touch or have no contact with each other. These forces act over an area called field. Gravitational and magnetic force are some examples of non-contact force. Moreover, you even discover the difference between balanced and unbalanced force. Again, what is balanced force? Very good! Forces that are equal in magnitude but opposite in direction are called balanced forces. Balanced forces do not cause a change in motion. When balanced forces act on an object, the object will not move. How about unbalanced force? Forces that cause a change in the motion of an object are unbalanced forces. Unbalanced forces are not equal and in opposite direction. Okay, students, did you understand the concepts of force? That's good. Now we are done with the review and it is time to do the pre-test. Kindly open your module on page 2 and answer the questions on number 1 to 10. Are you ready? Very good. Let's read the instruction together before we start. Instruction: choose the letter of the correct answer. Write your answers on a separate sheet of paper. Number 1. Who formulated the 3 laws of motion? A. Aristotle. B. Isaac Newton. C. Thomas Edison. D. Alexander Graham Bell. Answer: letter B. Isaac Newton. Number 2. Which has more mass? A kilogram of cotton or a kilogram of iron? A. The iron. B. Dichotomy. C. They both have the same mass. Or D. Cannot be determined from the given information. Answer: letter C. They both have the same mass. Number 3. Which has the greatest inertia? A. Airplane. B. Car. C. Jeepney. D. Bike. Answer: letter A. Airplane. Number 4. Which of these vehicles moving at the same velocity is difficult to stop? A. A bus. B. A car. C. A train. D. A truck. Answer: letter C. A train. Number 5. All of the following apply the third law of motion except A. Kicking a ball. B. Rowing a banka. C. Throwing a stone. Or D. Taking out ketchup from a bottle. Answer: letter A. Kicking a ball. Which of the following statements are true? 1. Action and reaction forces occur in pair. 2. Action and reaction forces act on the same object. 3. Action and reaction forces can occur one at a time. 4. Action and reaction forces have the same magnitude. A. 1 and 2. B. 1 and 4. C. 2 and 3. D. 2 and 4. Answer: B. 1 and 4. Which Newton's law explains when a man is pushed forward in the car as it stops? A. First law. B. Second law. C. Third law. D. Second and third laws. Answer: A. First law. Number 8. In Newton's first law of motion, a moving object that is not acted upon by a net force will blank. A. Accelerate. B. Change its velocity. C. Eventually come to a stop. D. Continue moving at constant velocity. Answer: B. Change its velocity. 9. A boy jumps out of the boat into a dock. As the boy moves forward to the dock, the boat moves backward. Which statement describes this situation? A. An object at rest remains at rest. B. Friction opposes the motion of an object. C. For every action, there is an equal and opposite reaction. Or D. The net force is directly proportional to mass and inversely proportional to acceleration. Answer: letter C. For every action, there is an equal and opposite reaction. Number 10. Two balls are simultaneously applied with a force of 20 Newton. One ball has a mass of 0.3 kg and the other has 0.4 kg. Which ball has greater acceleration? A. They will both accelerate at the same rate. B. None of them will accelerate greater than the other. C. The one with a mass of 0.3 kg has the greater acceleration. Or D. The one with a mass of 0.4 kg has the greater acceleration. Answer: letter C. The one with a mass of 0.3 kg has the greater acceleration. Well done, learners! You are now ready to proceed with our lesson. What do you think would be our lesson for today? That's correct! This time, we will discuss with you the 3 laws of motion. We hope that you will be able to achieve our objective for today. What would be our objective? At the end of this session, you will be able to infer that when a body exerts a force on another, an equal amount of force is exerted back on it. So, are you now ready to listen? Fabulous! Now, sit back and relax, because after a short break, we will start our lesson.
The Radyo Z-eskwela program of the Division of Davao de Oro is being brought to you by Nueda Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Archicons Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
We are back, learners. We will discuss this time the Newton's 3 laws of motion. But before that, let us acknowledge first the man behind these laws. Do you know who this man is? Yes, you are correct. His name is Sir Isaac Newton. Sir Isaac Newton formulated the 3 laws of motion. Are you familiar with the 3 laws of motion? Let's discuss the 3 one by one. Newton's first law of motion is commonly called as the law of inertia. The law of inertia states that an object at rest will remain at rest, and an object in motion will continue to move at constant velocity or constant speed in a straight line, unless acted upon by unbalanced force. To understand the Newton's first law of motion, we need to know first the inertia. Let's have an example. Consider yourselves that you are riding on a bus. Initially, the bus is at rest. When it starts to move, what will happen to you when the bus starts to move? Oh, your body has the tendency to move backward. On the other hand, when the car suddenly stops, your body has the tendency also to move forward. More so, when the car either starts to move or suddenly stops, your body has a tendency to change your state of motion. Inertia is the tendency of an object to maintain its state of rest or of uniform velocity in a straight line. The mass on an object measures the inertia of an object. The greater the mass of an object, the greater the inertia, and the harder it is to move when it is at rest, or difficult to stop when in motion. Are you learning now about inertia? Very good! This time, let's check your ideas. Which has more inertia? A phone or a television? Again, which has more inertia? a phone, or a television? Wow! Fabulous! It is the television because it has a greater mass. Now, let's proceed to Newton's second law of motion, which is commonly known as the law of acceleration. As we all know from the first law, to overcome inertia of an object, we need to apply unbalanced force. Newton's second law explains how fast the object will move. Well, the law of acceleration states that the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to the object's mass. In mathematical terms, Newton's second law states that force is the product of mass and acceleration. To cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. Let us imagine these two swings, one with a little kid and the other one with a fat man. If you applied the same force on both swings, which do you think will move or accelerate faster? Yes, you are correct. Now, push this fat man with the same force. See, it does not go further because it has more mass than the little kid. So, the more mass there is, the force required to push an object is also greater. Now, let's think on the mathematical formula of the second law of motion again. The equation can be stated in three forms. First, if you were to find the force, you need to multiply the mass by its acceleration. Again, in finding the force, just multiply the mass and the object's acceleration, or F is equals to m times a. Can you write it there? Very good. Next is finding the mass. You need to solve the problem by dividing the force by its acceleration, or m is equal to force divided by acceleration. More so, in calculating the acceleration, a solution would be a force divided by its mass, or A is equal to F divided by m. Did you follow or capture conversion? Wow, amazing! Now, in page 10 to 11 of your module, examine and understand the problems given in your module. In problem 1, it shows how to find the force, while in problem 2, it shows how to solve the acceleration. More so, in problem 3, it shows how to calculate the mass. So let's try to solve problem number 1. The problem goes like this. A 1,000 kilogram truck is traveling at an acceleration of 4.5 thousand meters per second squared east. Find the net force needed to accelerate the truck. First, look for the givens presented in the problem. The givens are the following. Acceleration is equal to 4.5 thousand meters per second squared east, and mass is equal to 1,000 kilograms. Now, what is missing is the force. Then, go for the solution. Since we are going to find the force, the formula in calculating force is equal to mass times acceleration. Then, substitute all the givens to the formula. Force is equal to 1,000 kg, which is the mass, times 4,500 meter per second squared east, which is the acceleration. And now, the answer is force is equal to 4,500 kg meter per second squared east, or 4,500 Newton east. Okay, students, did you get it? Very good. Now it's your time to shine. Can you try to solve this problem? An object with a mass of 4.0 kg accelerates at 4.0 meter per second squared when an unknown force is applied to it. What is the amount of force? Okay, what's the answer? Do we have the same answer? Great! The answer is 16 kg meter per second squared, or 16 Newton. Wow! It shows you understand the lessons well. And now, let us continue the Newton's third law of motion. Let's have this example. Have you ever wondered why a cannon moves forward when it shoots its cannonball? This sample applies to Newton's third law of motion. The third law of motion is the law of interaction, which states that for every action, there is always an equal and opposite reaction. This law tells us that a force exerted on any object is always exerted back by an equal magnitude of force, but in opposite direction. Always remember that in this law, forces always come in pairs. These are called action and reaction forces, and they do not act on the same body. In determining the action and reaction forces, you should be able to identify first the action that requires force, and then identify the reaction force that counteracts the action force. An example of this is dropping a basketball ball. As the ball hits the floor, it causes a downward force on the floor. This is the action. Then, the floor reacts by pushing off the same force but in opposite direction, and this is now the reaction force. Another example of this is a boy pushing a wall. When the boy pushes the wall, which is the action, the wall exerts an equal and opposite magnitude of force to the boy, which is the reaction. Now, think of other examples which could be applicable to the third laws of motion. Good job, learners! We are done with the discussion on the Newton's three laws of motion. So, can we recall the three laws of motion? The first law is the law of inertia, which states that an object at rest will remain at rest, and an object in motion will continue to move at constant velocity unless acted upon by a net force. The second law is the law of acceleration, which states that the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to the object's mass. The direction of the acceleration is the same as the direction of the net force acting on the object. And the third one is the law of interaction, which also states for every action there is always an equal and opposite reaction. That's all for today, grade 8 learners. We are finally done with our discussion. So, I guess you are ready now to take the quiz. After this short break, kindly prepare 8 sheets of paper for our evaluation. Good luck and God bless.
The Radyo Z-eskwela program of the Division of Davao de Oro is being brought to you by Nueda Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Archicons Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
I'm back, learners. Are you now ready for your quiz? I guess you are quite ready and excited. Learners, kindly open your module on page 18 to 19. Let us read the instruction together. Instruction: choose the letter of the correct answer. Write your answers on a separate sheet of paper. Number 1. What is the definition of weight? A. The size of an object. B. The time it takes to get on a ride. Letter C. The amount of matter in an object. Or letter D. The magnitude of the force of gravity on an object. Number 2. Which law states that forces act with equal magnitude and in opposite direction? A. Law of inertia. B. Law of interaction. C. Law of acceleration. And D. Law of gravitational force. Number 3. For every blank, there is an equal and opposite blank. A. Action, action. B. Reaction, action. C. Action, reaction. Or D. Reaction, reaction. Number 4. What Newton's law of motion requires the use of seat belt in cars? A. Law of inertia. B. Law of interaction. C. Law of acceleration. Or D. Law of universal gravitation. Number 5. A guava with a mass of 0.200 kg has a weight of blank. A. 0.200 Newton. B. 1.96 Newton. C. 4.50 Newton. Or D. 10.0 Newton. Number 6. A stone hits the ground before a flat sheet of paper because of blank. A. It is less massive. B. It is more massive. C. The acceleration of gravity is greater on the stone. Or D. There is more air resistance against the flat paper. Number 7. If the mass of an object is 45 kg on Earth, what is its mass on the Moon? A. 45 Newton. B. 45 kg. C. 441 Newton. Or D. 441 kg. Number 8. Which of the following phenomena applies the first law of motion? A. A leaf sways back and forth falling from a tree. Letter B. When a ball falls on the floor, the ball bounces back up. Letter C. When pushed with the same force, a car accelerates slower than a grocery cart. Letter D. When a cardboard with coin on top is suddenly pulled, the coin falls into the glass. Number 9. According to the second law of motion, the net force is the product of mass and acceleration. Which of the following has the greatest acceleration? A. A 5-kilogram stone pulled with a 10 Newton net force. B. A 0.5 thousand kilogram toy car is pulled with a 9 Newton net force. C. A 7 kilogram metal ball is pushed by a 17 Newton net force. Letter D. A 500 kilogram truck accelerated by 1000 Newton net force from its engine. In a grocery store, you can easily push a cart with 5 kilogram sack of rice, then a cart with a 10 kilogram sack of rice to the counter. Which of these explains the situation? A. Law of inertia. B. Law of interaction. C. Law of acceleration. D. Law of universal gravitation. Let's check your work. Answers. Number 1, D. Number 2, B. Number 3, C. Number 4, A. Number 5, B. Number 6, D. Number 7, B. Number 8, D. Number 9, B. Number 10, C. Who among you get perfect? Very good. How about those students who get below the median? Good. Nothing to worry about. We still have plenty of assessment on the preceding topics. Once again, congratulations everyone. Again, we hope that you were able to infer knowledge on about the concept and the 3 laws of motion. Also, we hoped that you were able to understand that when a body exerts a force on another, an equal amount of force is exerted back on it. Once again, thank you so much for listening and see you in next session through radio-based instruction. Again, I am Teacher Sushmita from Andap National High School, and together with me is Sir Eliezer for the class on the air in grade 8 science. For those concepts which is not clear to you, you can put your comments, suggestions, and questions on our FB page. Thank you so much.
Radyo Z-eskwela Executive Committee. The School's Division Superintendent, Eufemia T. Gamutin Seso 5. Assistant Schools Division Superintendent, Dr. Romel R. Handayan. OIC Curriculum Implementation Division Chief, Karina S. Frasco. School Governance and Operations Division Chief Dr. Ruben J. Riponte. Members: Cecilia Morales, Dr. Hilda A. Opeña, Dr. Arlene D. Lim, Dr. Eldicris B. Calzadora, Dr. Dexter A. Siquinia, Nohara O. Pinute, Noemi P. Canales, Dr. Grace D. Pontillas, Virgilito C. Pabrices, Juanito Lapiceros, Engineer Norberto S. Manlangi, Jomar M. Dumupoy, Bob Dalan S. Milabat, Medard T. Ampit, and Paz Eugenia Villusino. Technical Working Committee, Productions and Communications, Lorely E. Quijano, Given G. Hinampas, Judyland D. Yu, Donna D. T. Bolifer, Mary Rose N. Resma, Riven Manuel, Irene Lea C. Manguhon, and Bessie Aya N. Banias. Social Media and Packaging Team, Christian and Hara L. Martesio, William R. Ranara, Joan T. Iscoton, Roberto S. Acusar Jr., May B. Istanyol, Richard H. Arellano, Lee L. S. Blanco, Ralph A. Tabanyag, Angelo Gutierrez Jr., and Jade Karen Arais.